What I want to do in this video is revisit some ideas that you've probably taken for granted since the time that you were like 3 or 4 years old. But when hopefully you'll kind of view it in a new light, and it'll help inform us when we think about other types of number systems. So we have 10 digits in our number system. So let me just start counting. So if I have nothing, I use the symbol 0. Then if I have one object, I use the symbol 1. Actually, let me draw this out. So nothing. Then if I have one thing, I use the symbol 1. If I have two things, I use the symbol 2. If I have three things, I use the symbol 3. Let me scroll down a little bit, make sure you can see that. If I have four things, I use this symbol right over here. If I have five things, I use this symbol. If I have six things, let's draw it like that. If I have six things, I use that symbol. If I have seven things, I use that symbol. I know might be getting a little bit tedious, but this all has a point. If I have eight things, I use this symbol. And if I have nine things, I use this symbol. And then if I have 10 things, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What symbol do I use? I've already used up my 10 digits. We only have 10 digits in a base 10 system, so we start reusing them. So what we do is we introduce this idea of number places. You say that I have 1 10 and 0 ones. So you say you have 1 10 and then 0 ones. And then 0 ones. We call this 1, we say it's in the tens place. This is literally saying 1. This is saying 1 tens. This is 1 tens plus 0 ones. So that's what this is saying. But we didn't have to reuse it. We could have had maybe more symbols. Maybe this was a symbol or maybe we would have created a new symbol instead of, all of these had their own symbols. So instead of having to reuse the old ones, maybe we could have made the symbol star for 10. And then when you go to 11, maybe we would have had another symbol for that. But let me go to 11 just to hit the point home. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 in our number system, we say that this is 110. We say this 110. Let me write it this way. 110. And then this is also, it's 110 and then 1, 1. And then 1, 1. So it's 110 plus 1, 1. I know this is kind of strange to see it this way, but it represents this number of objects. If we had a base 11, or I guess we could say base 12 number system, maybe we would have had a symbol for this instead of reusing our old digits. Maybe a symbol could have been something wacky. Maybe it would have been a smiley face. Who knows what it would have been? And I'll introduce higher number base systems in kind of future videos where we see what kind of the symbols that are actually used. But what I want to do in this video is think about how would we count, or what symbols would we use if we had fewer digits? And in particular, how would we count things if we only had two digits, if we only had 0 and 1? And essentially what we're going to do is think about how we would represent numbers in base 2. Our traditional number system is a base 10 number system. We have 10 digits, 0 through 9. How would we count in base 2? So if you have 0 things, you'd still probably say, hey, I have 0. I can use the digit 0. If I have one thing, I could still say, hey, I have one thing, because we have the digits 0 and 1. So let me make it clear. The digits here, the digits in base 2 can be 0 or 1. So if I have one thing, I can still use the number 1. But now all of a sudden I have these two objects here. And I'm saying that I'm limited to only these two digits over here. So how could I represent it? Well, instead of having a tens place, I could create a twos place. And I know it might sound a little bit counterintuitive, but I think you'll get used to it a little bit. So over here in base 10, we said we had 110 and 0 ones. So in base 2, why can't we say that we have 1 2, 1 2, and 0 ones? Let me make that clear. So this is right here is saying 1 1 2 and 0 ones. 0 ones. I want to make sure you understand the analogy here. In base 10, let me write a larger number in base 10. So if I write the number 256 in base 10. So this is base 10 over here. What is this saying? This is saying 2 hundreds. So 2 times 100, or maybe I should write down the word because I don't want to confuse the symbols. 2 hundreds plus 5 times, or maybe I should say 2 hundreds plus 5 tens. 2 hundreds plus 5 tens plus 6 ones. That's what I represent here. And the way we know that is that we know that if we go 2 places to the left, this is the hundreds place. Hundreds place. This is the tens place. And this is the ones place. And if you know from your exponents, this is equal to 10 times 10. This right here is equal to 10 times itself only once. And this is equal to 10 times itself, I guess you could call it 0 times. Or if you know your exponents, this is 10 to the second power. This is 10 to the first power place. And this is 10 to the 0th power place. And if you added another digit here, that would be the thousands place, which would be 10 times 10 times 10. We're going to do the exact same thing in base 2, but instead of using 10, we're going to use 2. So now this is the 2's place. This is the 2's place over here. This is the 1's place. If we add more digits, let me make it clear. So in base 2, so let me write a number here in base 2. And remember, in base 2, I can only use zeros and 1s. So in base 2, maybe I have the number 1, 0, 1, 0. So when you think about it this way, if this was base 10, you would call this the tens place, the hundreds place, and the thousands place. But this is base 2 now. So let me be very clear. We are only using 2 digits. So in base 2, this right here, this is still the ones place. Now this is going to be the 2's place. Remember, in base 10, this was the tens place. Now this is the 2's place. Now this would be, and you could take a guess here, hundreds was 10 times 10. When we go two spaces to the left in base 2, this should be the 2 times 2's place, or this is the 4's place. This is the 4's place. This over here is going to be the 8's place. So if you wanted to kind of think about this in terms of base 2, this is 1, 1, 8 plus 0 4's plus 0 4's plus 1 2's, 1 2's plus 0 1's plus 0 1's. So if you wanted to represent this exact same number in base 10, it's 1 8 plus 1 2. So in base 10, this would be, let me write it over here. In base 10, this would be an 8 plus a 2, which is just a 10. So this is it in base 10. This is how you would represent what we know as this many things, as 10 things. This is how you would represent it in base 2. This is how we know we would represent it in base 10. Now let's continue here, just to make sure we understand things. So this many objects. Well, in base 2, we have one. If we just have 2 objects, that's 1, 2, and 0 1's. Now 3 objects would be 1, 2, plus 1 1's. So let me do it over here. So this would be 1, 2 plus 1 1. So this is 3 objects in base 2. Now when you go to this, so over here we have 1, 4, 1, 4, 0 2's, and 0 1's. So now we're going to go to the 4 place, because we've essentially maxed out everything here. If we increment more, we have to go to one more place, just like we did in base 10. But now we can only use the digits 0 and 1. So now we'll have 1, 4, 0 2's, 0 1's. Now when we add one more, we're going to add one more 1. So now we have 1, 4, 0 2's, and 1 1. And just to be clear, this is this many things. This is this many things in base 2. This is the 4th place, 1 4 and 1 1. If you wanted to convert this into base 10, you'd say, look, this is 1 4. This is 1 4, 0 2's, and 1 1. So if you have a 4 and a 1, we would represent that with the symbol 5 in base 10. We don't have that symbol available to us in base 2. Let's go to this. So now we're going to increment one more. So how can we represent that in base 2? This is definitely, we're going to have 1 4. And then we're going to have 1 2. And then we're going to have 0 1's. And if you keep, it's kind of fun to practice counting in base 2. You'll start to get the hang of it. So here we have to add 1 1 to this. So we get 1 1 1. And now when we get to 8, there's no way to kind of increment any of these any higher. So we have to get a new place. We have to go to the 8's place. So we have 1 8, 0 4's, 0 2's, and 0 1's. This right here, it might look like 1,000 to you, but it would be 1,000 if we were in base 10. In base 2, this is this many objects. This is 8 objects in base 2. When you increment it 1, we'll have this many. We'll have 1, 8, and then we'll have 1, 1. So it'll be 1, 0, 0, 1. And then I'll stop here at what we consider to be 10 objects. In base 10, you would say you have 1, 8, 1, 8, and you would need 1, 2. So you'd 0 4s, 1, 2, and 0 1s. So this right here is 10 in base 2. This is 10 in base 10. Hopefully that doesn't confuse you too much.